Hello friends, in this module we will be learning about packaging of cereals and cereal flours along with packaging of breakfast cereals which are generally made from cereals and cereal flours. The major problems in the packaging of cereals and cereal flours are related to the moisture content, absorption of moisture, oxidation of fat, and due to that the loss of crispness, and sometimes it also relates to the lipid oxidation which causes the deterioration. So, starting with cereals are considered to be fruits of cultivated grasses. They are members of the monocotyledonous family Gramineae. The principal cereal crop are wheat, barley, oats, rye, rice, maize, sorghum, and some other millets. Cereals have been important crops for thousands of years, and the successful production, storage, and use of the cereals has contributed largely to the development of modern civilization. Today, cereals and cereal based products are an important part of the diet in most countries, and each year new products based on cereals are developed and marketed to increasingly urban consumers. The cereals are harvested, transported, and stored in the form of grains. The anatomical structure of all cereal grains is basically similar, differing from one cereal to another in detail only. The mature grain of common cereals consists of carbohydrates, proteins, lipids, minerals, and water, together with small quantities of vitamins, enzymes, and other substances, some of which are important nutrients in human diet. Carbohydrates are quantitatively the most important constituents, forming 77 to 87% of total dry matter of the cereals. The lipids in milled cereals are likely to undergo two types of deterioration: hydrolysis from endogenous lipases and oxidation from endogenous lipoxygenases or molecular oxygen. Destruction of the grain and the fragmentation that occurs in milling promote deterioration by bringing the lipid and the enzyme together. The structure and quality of grains changes due to various processing steps applied. The threats to grains during storage are mainly moisture, temperature, fungi, bacteria, insects, rodents, and some other pests. If the grain moisture content can be controlled, the threats due to temperature rise, fungi, and insects can largely be controlled. It is not the moisture content that is important for long term storage, but rather the water activity. A safe moisture content for long term storage of grain and oil seeds usually being accepted as one in equilibrium with 70% relative humidity, that is 0.7 water activity. Above 0.75 water activity, molds will grow rapidly during the storage with subsequent deterioration. Thus, the loss of product will occur. Moisture sorption isotherms for wheat, barley, and maize have been published, and all have a typical sigmoid shape. The moisture content equivalent to 0.7 water activity varies quite significantly among the different grains. Thus, stressing the utility of expressing stability in terms of water activity rather than moisture content is important. Storage of grains take many forms, ranging from piles of unprotected grains on the floor, underground pits or containers, and piles of sacked grains to storage bins of many sizes and shapes. It is essential that the grain has been dried to a moisture content equivalent to 0.7 water activity or less before packing and storage. Consumer packages for grain commonly consist of heat sealed pouches made from LDPE, that is linear low density polyethylene. This provide a satisfactory moisture barrier and result in required shelf life of the grains. Now, we will talk about wheat grain or packaging of wheat grains. The wheat grain is a live respiring organism commonly carrying endemic fungi. Respiration is slow at 14% moisture content and 20 degrees centigrade, but increases as the moisture content and temperature increases. The process of respiration generates heat, which is difficult to remove since wheat is a poor conductor as well as carbon dioxide and water vapor, resulting in loss of weight. Except the grain is turned over to allow evaporation of the water, it will sweat and become caked in the storage. Moisture contents of 16 to 30% can support fungal growth in wheat, thus there is the risk of mycotoxin production. Above 30% moisture content, it is susceptible to bacterial infestation, leading to spoilage, excessive heat production and possibly charring. Insect life is also becomes more active as the temperature rises, and because of their respiration, live insects in grain also increase the grain temperature. Deterioration during storage is intensified by mechanical damage during harvesting, since microorganisms attack damaged grains more readily than intact grains. A drop of 3% in moisture increases the shelf life 4 times. The major problems at this higher moisture contents include accelerated wheat enzyme activities and microbial spoilage. The next important cereal is rice. It is consumed in large quantities in many countries. Brown or unmilled rice is more nutritious than milled rice, but storage stability problems and traditional consumer preference for whole rice have limited the quantities of brown rice packaged and sold for direct consumption. A major limiting factor to less use of brown rice is accumulation of free fatty acids in rice stored under warm and humid conditions. Fatty acids can be released by lipase activity present in the rice bran layer of damaged grains by high lipase containing microorganisms adhering to rice. In a study to evaluate the effects of carbon dioxide gas flushing on the shelf life of brown rice, greater stability of the rice was obtained at refrigerated storage when it was packaged in nylon EVA copolymer laminate film rather than regular plastic film bag. However, no differences were found when stored at 24 degrees centigrade. The gas flushed bags formed a hard rigid pack similar to a vacuum packaged product and maintained this appearance for at least 3 years. It was suggested that if bulk rice in warehouses could be stored as brown rice instead of a rough rice in laminate or gas flush bags, savings of at least 20% by weight and 30 to 35% by volume can result. We will learn about the flours. Till now we have learned about packaging of different whole grain cereals. Now we will learn about flours, and after that we will change over to the breakfast cereals, which are the processed form of various cereals. Now we will talk about flour. So, first of all, wheat flour. Wheat flour is the ground or milled form of wheat grain in which the bran and germ are partly removed and the remainder is comminuted to a suitable degree of fineness. It has been suggested that for long periods of conservation, flour should be stored in a closed atmosphere. Under these conditions, floor acidity increases due to the accumulation of linoleic and linolenic acids. Flour is stored commercially in bags or in bulk bins. The threats to flour in storage are similar to those of wheat in storage, likely mold and bacterial attack, insect infestation, oxidative rancidity, and eventual deterioration of baking quality. The expected shelf life of plain white flour packaged in paper bags and stored in cool and dry conditions and protected from infestation is 23 years. The rate of increase in acidity increases with storage temperature and decreasing flour grade by increasing ash residue in the flour. Thus, the shelf life of brown and wholemeal flours is shorter than that of white flour. Freedom from insect infestation during storage can be guaranteed only if the flour is free from insects at the time of packing, and even the storage area is free from insect infestation. The use of multi-walled kraft paper bags, sometimes with an LDPE liner, completely eliminates any infestation hazard. The optimum moisture content for the storage of flour is related to the intended shelf life, the barrier properties of the packaging material, and the ambient conditions. For use within a few weeks, flour can be packaged at 14% moisture content, but at moisture content higher than 13%, mustiness due to mold growth may develop over a time. A moisture content lower than 12%, the risk of lipid oxidation and the development of rancidity increases. Australian millers maintain flour moisture contents below 12% for shipment to warm and humid areas, while in the United Kingdom, wheat flour is stored at maximum moisture content of 12%. Reference to a moisture sorption isotope shows that moisture content of 12% corresponds to water activity of 0.5. As with wheat and other grains, the moisture content is an unreliable means to measure stability, and what is required are moisture sorption isotopes at various temperatures, so that the moisture content which corresponds to maximum water activity for stability at a particular storage temperature can be determined. This will vary depending on types of grain as well as variety, but data on shelf life of flour at various water activities and values for critical moisture contents are missing, and it is therefore difficult to specify precisely the type of moisture vapor barrier required in a package. Notwithstanding the lack of information about critical moisture contents and shelf lives as a function of water activity, bags made from cotton, twill or paper have been used successfully for decades for consumer packs of flour. Kraft paper bags with an LDPE liner provides additional protection, thus gives a longer shelf life. We will talk about packaging of breakfast cereals. Breakfast cereals can be categorized according to the amount of cooking required, the form of product, and the cereal used as raw material. All cereals contains large amount of starch, which in its natural form is insoluble, tasteless and unsuitable for human consumption. It must be cooked or processed to make it digestible and acceptable. In hot cereals, the cooking is required to be done out in the home, while ready to eat cereals are cooked during manufacture or processing in the plant. If the cereal is cooked with excess water and moderate heat like in boiling, the starch gelatinizes and becomes susceptible to starch hydrolyzing enzymes in the human digestive system. If the cereal is cooked with a minimum of water or without water, but at higher temperatures as in case of toasting, Non-enzymatic browning between protein and reducing sugars may occur, and there may be some depolymerization of the starch. Now, we will discuss about characteristics of breakfast cereals. The ready to eat cereals probably originated from Seventh Day Adventist Church, whose members, preferring an entirely vegetarian diet, experimented with the processing of cereals in the mid 19th century. A granulated product called granola and made by J.C. Jackson in 1863 may have been the first commercially available ready to eat breakfast cereal. A similar product, also called granola, was made by J. H. Kellogg by grinding biscuits made from wheat meal, oatmeal and maize meal. Ready to eat cereals include flaked, shredded and granulated products, generally made from wheat, maize or rice, even though oats and barley are also used. The basic cereal may be supplemented with sugar, honey or malt extract. All types are prepared by processes which tend to cause hydrolysis or dextrinization rather than gelatinization of the starch. Flake products are made from wheat, corn, oat or rice after cooking at elevated pressure and the addition of flavoring such as malt, sugar and salt. Cereal is dried to 15 to 20% moisture content and conditioned for 13 days. It is then flaked, toasted, cooled and packaged. Shredded cereals are made from whole wheat grains which are cooked to gelatinize the starch. After cooling and conditioning, the grain is fed through shredders. The shreds are baked for 20 minutes at 260 degrees centigrade, dried to 1% moisture, cooled and packaged. Granulated products are made from yeast dough consisting of wheat flour and salt. The dough is baked at large loaves, then broken up, dried and ground to a standard fineness. Flaked cereals are sometimes coated with sugar to provide a hard, transparent coating that does not become sticky even under humid conditions. The sugar content of corn flakes increased from 7 to 43% as a result of coating process. There are 5 major modes of deterioration to be considered in the breakfast cereals and to be considered when selecting packaging materials for the breakfast cereals. The deterioration modes are moisture gain resulting in loss of crispness, lipid oxidation resulting in rancidity and off flavors, loss of vitamins, breakage resulting in aesthetically undesirable product and loss of aroma from flavored product. The shelf life of breakage cereals depends on content and quality of oil contained in them. Thus, products made from cereals having a low oil content such as wheat, barley, rice, maize grits have a longer shelf life than products made from oats. Although whole corn has a high oil content of around 4.4%, most of the oil is contained in the germ which is removed during manufacturing of grits. Now, we will discuss about packaging of breakfast cereals. Packaging of breakfast cereals has traditionally been in fiberboard boxes with a super calendared waxed glassine liner. Now, the glassine liner has been replaced by various plastic materials, in particular with thin gauge HDPE which is usually folded rather than heat sealed. HDPE co-extruded with thin layer of EVA copolymer is a recent introduction. The EVA copolymer allowing a lower heat seal temperature and offering the consumer an attractive and peelable seal. When the cereal product is not hygroscopic and holds a satisfactory texture when in equilibrium with ambient conditions, a liner may not be needed for moisture protection and may even serve to entrap rancid aromas. In such case, either no liner or one which is vapor permeable may be used. As well as providing a barrier to vapor, the liner must also restrain cereal aromas within and at the same time prevent foreign odors entering the packaged product. It should also be reclosable to protect from remaining cereal in the package. To minimize oxidative rancidity in the cereals, it is important that the package eliminate light. Excluding oxygen may be of limited assistance in extending shelf life. For this reason, most processors do not bother to use good oxygen barrier packaging. In a study of storage stability of flaked oat cereal packaged in materials of different oxygen barrier properties with and without the addition of an iron based oxygen absorber, the absorber delayed lipid oxidation provided that it was used with a packaging material such as PVC PVDC copolymer coated PP LDPE that was a good oxygen barrier. The use of an antioxidant in the package liner has been shown to be successful in extending shelf life, but is not generally permitted in most of the countries. In shredded cereals, rancid odors accumulates if shredded wheat is stored in an airtight container due to the higher unsaturated fat content. Therefore, it is usually sold in breather boxes without linings. When so packaged, the product is just as stable as any other prepared cereal, except that moisture absorption takes place more easily. The vitamin and mineral fortification of cereals is widely used in many countries. The major cause of vitamin loss in packaged cereals is the temperature of storage. In a study on the effect of processing and storage on micronutrients in breakfast cereals, it was found that micronutrient loss is not a major factor in determining the shelf life of dry cereals. There was no considerable loss of added vitamins during normal shelf lives, with the possible exception of vitamin A and C. Vitamin A survived 6 months at room temperature with no measurable loss. The rigidity and compression resistance of the carton together must provide the necessary resistance to protect the product from breakage throughout production line operations, storage and distribution. Rigidity also prevents the bulging of carton. Protecting breakfast cereals from breakage does not appear to be a problem using currently available carton stock and carton designs. Loss of flavor is a problem with certain cereal products to which fruit flavors have been added before packaging. In these cases, loss of flavor results in the product being considered to be at the end of its shelf life by the consumer. A study evaluating HDPE and glycine as liner found that permeability coefficients of D-limonene, which is a common flavor component in citrus products, in the HDPE liner were 3 to 4 times higher than in glycine. It was also found that the solubility of D-limonene in the glycine liner was significantly lower than in HDPE liner for the same vapor pressures. Hence, equilibrium distribution of the limonene vapor between a product such as fruit flavored cereal and the respective liners will result in a lower limonene concentration within the glycine liner, and scalping of flavor can be expected to be more significant in HDPE liner. Moisture and temperature are the major factors affecting the shelf life of cereal grains and their flours. So, the packaging materials used should have good moisture barrier properties for grains, while in case of flours, the packaging material should also prevent light. The primary mode of chemical deterioration in dry breakfast cereals is lipid oxidation, and two reasons have been advanced for this. First, water activity of dry cereals is at or below the monolayer, which essentially stops all the types of deteriorative reactions. Second, unsaturated fats are required in lipid oxidation, and the grains used in breakfast cereals have a high ratio of unsaturated to saturated fats. Thus, the limit laminated liners with aluminum foil can be used with paperboard cartons which prevents light and moisture both. So, friend, to conclude this module, I would like to say that we have seen that the moisture, temperature and fat oxidation plays a major role in deterioration of cereal and cereal based products. So, to avoid that, the packaging material used should be designed in such a way that it gives a good barrier properties against these conditions. So, thus if we use a laminated aluminum pouch or a laminate which is containing aluminum foil or metallized aluminum, then it gives a good light barrier, moisture barrier properties, and if it is stored at optimum conditions, then the shelf life of the cereal products can be increased.